A universe of anticipation surrounds us. SpaceX's Starship is the vessel designed to take us there. This colossal rocket represents more than just engineering. It embodies a bold vision, a vision of cities on Mars, a vision of lunar bases. Each test flight is a step towards that grand future. Each launch carries the hopes of millions. The anticipation for Starship Flight 9 was immense. Flight 9 was not just another test, it was slated to push the boundaries further than its predecessors. After the incremental successes and valuable lessons from previous flights, this mission aimed for new milestones. The global community watched Starbase, SpaceX's development facility, with bated breath. Online forums buzzed with speculation. Livestream viewership was expected to break records. This was a moment many had marked on their calendars, a testament to our collective yearning for exploration. The official word from SpaceX, delivered on May 20, 2025, was concise. Starship Flight 9 would not launch on its scheduled date. The company cited the need for additional system checkouts. This phrase, common in the aerospace industry, can cover a multitude of factors. It signals a cautious approach. It underscores a commitment to mission success over adherence to a strict timeline. Reactions to the delay were varied, yet largely understanding. The space community, seasoned by decades of launches, knows that scrubs and postponements are part of the process. Disappointment was certainly present. Many had made plans to watch, to report, to analyze, yet this was overshadowed by a prevailing sentiment. Better safe than sorry. The memory of past space tragedies serves as a constant reminder of the stakes involved. A catastrophic failure with Starship would be a significant setback, not just for SpaceX, but for the broader dream of interplanetary travel. Thus, patience became the watchword. In the absence of immediate, detailed explanations, speculation naturally began to fill the void. Slowly, details began to emerge regarding the specific technical gremlins that prompted the Flight 9 postponement. Sources close to the Starship program, and later, more direct communications from SpaceX officials, pointed towards a confluence of issues. One primary concern reportedly involved anomalous readings from several Raptor V3 engines during late-stage pre-flight testing. These engines, the workhorses of Starship, operate under extreme pressures and temperatures. Even slight deviations in performance parameters can warrant a thorough investigation. Elon Musk, in a subsequent tweet on May 22, 2025, elaborated slightly. He mentioned unexpected resonance signatures in a few booster engines during the final spin prime tests. This kind of vibrational issue can be serious. It could lead to premature wear, component failure, or even a catastrophic engine shutdown during ascent. Musk added, also refining some parameters in the stage separation pneumatic system. The stage separation mechanism, crucial for the mission's success, must work perfectly. Any doubt necessitates a pause. The sheer complexity of the Starship system cannot be overstated. Each component, from the smallest sensor to the giant propellant tanks, must function within precise tolerances. Section 4. Guardians of the Ascent. The primacy of safety in space endeavors. In the grand theater of space exploration, delays are not merely inconveniences. They are often vital safeguards. They represent a commitment to the principle that safety must always trump schedule. This philosophy is deeply ingrained in the DNA of every reputable space agency and company. The allure of a spectacular launch can be strong. The pressure to meet deadlines can be intense. However, the potential cost of a failure, measured in lives, resources, and public trust, is immeasurably greater. Therefore, a decision to postpone a mission, like that of Starship Flight 9, is frequently a sign of responsible engineering and mature decision-making. The history of spaceflight is punctuated by moments of triumph, but also by somber reminders of its inherent dangers. Tragedies like Apollo 1, Challenger, and Columbia serve as indelible lessons. They teach us that space is an unforgiving environment. It tolerates no shortcuts. It punishes complacency. Every engineer, every technician, every mission controller involved in a launch carries this heavy awareness. Thoroughness is not just a virtue, it is a necessity. The decision to delay Flight 9 therefore should be viewed not as a setback, but as a testament to their adherence to the fundamental principles of safe space operations. Section 5. The SpaceX Way, iteration, data, and relentless progress. SpaceX operates under a distinct philosophy, one that has disrupted the traditional aerospace industry. This approach can be summarized as test, fly, learn, iterate. Unlike programs that might spend decades perfecting a design on paper and in simulations before the first full-scale test, SpaceX embraces a more dynamic, hardware-rich development cycle. They build, they fly, and sometimes they experience what they famously call rapid unscheduled disassemblies, or RUDs. These are not seen merely as failures but as invaluable learning opportunities, providing a wealth of real-world data that is difficult, if not impossible, to obtain otherwise. Previous Starship prototypes have indeed experienced their share of spectacular RUDs. Each event, however, has been meticulously analyzed. The data from thousands of sensors, telemetry streams, and high-speed cameras are pored over by engineers. What went wrong? Why did it go wrong? How can we prevent it from happening again? This iterative loop of building, testing, failing, or succeeding, and then rapidly incorporating lessons learned into the next design is a hallmark of SpaceX's genius. It allows for a much faster pace of development even if it appears more chaotic from the outside. Each flight, successful or not, pushes the program forward. The delay of Flight 9 fits perfectly within this paradigm. By identifying these potential problems on the ground, or through rigorous pre-flight analysis, SpaceX can implement fixes and improvements. Section 6. Forging Ahead. SpaceX's Blueprint for Overcoming Obstacles. Following the announcement of the delay for Starship Flight 9, SpaceX did not simply stand idle. The teams at Starbase in Boca Chica, Texas, are renowned for their relentless work ethic and problem-solving capabilities. The blueprint for addressing the identified hurdles involves a multi-pronged approach. Detailed inspections and diagnostics on the Raptor engines exhibiting unusual resonance signatures would be paramount. This could involve disassembling affected engines, conducting further ground tests on individual units, or even implementing design tweaks to mitigate such vibrations in future engine builds. The goal is to ensure robust performance across the entire engine cluster. The refinements to the stage separation pneumatic system, as mentioned by Elon Musk, would require careful engineering adjustments. This system is vital for ensuring that the Starship upper stage separates cleanly from the Super Heavy booster at the correct moment. Any imprecision here could lead to mission failure. Engineers would likely be running simulations, testing components, and possibly modifying hardware or software controlling the pneumatic actuators. Beyond these specific issues, SpaceX's contingency plans often involve having backup hardware and rapidly adaptable software. If a particular engine is deemed problematic, it can often be swapped out relatively quickly. Software patches can be developed, tested, and uploaded to address control system anomalies or refine operational parameters. The company's vertical integration, where it designs and manufactures most of its components in-house, provides a significant advantage in terms of speed and flexibility when addressing technical challenges. Section 7. The Starward Gaze, Resilience, and the Future of Interplanetary Travel. The delay of Starship Flight 9 does little to dim the audacious vision that fuels SpaceX. The ultimate goal remains unchanged: to enable human colonization of Mars. Starship is the linchpin of this grand ambition. Each test and challenge overcome is a step along that extraordinary journey. These hurdles refine the path and strengthen the vessel for immense voyages ahead. Overcoming obstacles is fundamental to the maturation of any aerospace program. Each problem solved adds to the collective knowledge base. It makes the vehicle more robust, reliable, and safer. The resilience of the SpaceX team is a testament to their dedication. They operate in a high-stakes environment where the margin for error is small. Their ability to adapt and push forward is critical to the success of Starship and humanity's future in space. The lessons from Flight 9 will be invaluable. They will inform future Starship designs and missions to the Moon, Mars, and beyond. The stars still await, and Starship will continue its journey, carrying our aspirations for a future where the sky is only the beginning.